I'm Tim Ventura, and we're joined today by Dr. Seth Shostak, the senior astronomer for the SETI Institute. And today we're talking about his organization's mission to explore, understand, and explain the origin, nature, and prevalence of life in the universe. Seth has a PhD in astronomy from Caltech and a BA in physics from Princeton University. He's been awarded the Carl Sagan Award for the Popularization of Science and the Klumpke Roberts Award for Astronomy Popularization. He hosts SETI's weekly radio show and podcast, Big Picture Science, and has played himself numerous times in TV and internet film dramas and has acted in several science fiction films. Seth has co-authored a college textbook on astrobiology and has written 3 trade books on SETI. In addition, he's published over 400 popular articles on science, including regular contributions to NBC News, gives dozens of talks annually, and does regular outreach to students interested in science and astronomy. So Seth, welcome back. It is truly a pleasure and an honor to have you with me today.
Well, I'm happy to be here, Tim.
So last time we talked, our focus was really on the technical challenges of the SETI project. So today I was hoping to explore some of the big picture concepts that inspire it in the first place. And it seems like the best place to start there is with Project Breakthrough Listen, which is a $100 million initiative funded by Yuri Milner, called the most comprehensive search for alien communications to date, and estimated to generate as much data in one day as previous SETI projects generated in a full year. So let me ask, how is that project going? And does the volume of data collected create its own issues in terms of analysis?
Yeah, well, actually, I'm not a member of that particular team. So how it's going, I don't know. But it is going. I mean, it started around the first of the year. So there's been half a year worth of effort there. And it's a very clever idea because what it does is instead of trying to use a telescope exclusively, we got this big antenna and you SETI guys can use it for the next, year or something like that. That's typically what SETI has done in the past. This thing just sort of, it's like inserting an additional tap into the pipeline of data for the Very Large Array, which is this instrument of 27 antennas down in northern New Mexico. So what it's doing is it's piggybacking on some science and to get data that it then examines, hoping to find a signal that's of the type that aliens might put into space.
Well, another big picture topic is artificial intelligence. And one of the reasons that I started with Breakthrough Listen is that project performed a deep learning-based SETI search for radio technosignatures and uncovered 8 new signals previously missed by classical techniques. So it seems like those dovetail together very well. Can you tell me a little bit about how innovations like that are empowering SETI?
Yeah, well, people will often ask, look, you guys are, trying to eavesdrop on the aliens. What's new about that? Or how are you doing it differently? Or why should that be in the newspapers, if you will? And usually the answer is, well, it's just the march of technology, right? Moore's law, which is sort of a very well-known law here in the Silicon Valley where I am, says that every 2 years, the amount of compute power you can buy per dollar doubles. So the computers are getting faster all the time. And does that help in terms of finding a signal due to ET? The answer is yes, it probably does, because it's not that you're finding it faster, although you might be, but it's the fact that you can look over more of the radio dial or more spots on the sky. It speeds up the search. So the way I think about this, it's like, okay, we're going to drop you off in this South Pacific island, and there's some buried treasure in there, we think. Here's a teaspoon. Start digging for it. And every 2 years, that teaspoon doubles in size until it's, the size of a shovel or maybe even a skip loader. So that's what we're doing here, improving the technology to speed up the search to maybe shorten the time before we can tell you that we found ET.
And that's wonderful. One of the reasons that I got into these was I've been doing a lot lately on the Drake equation and studying the galaxy, and just the vastness of scales is so enormous that I think it's difficult for most people to really intuitively accept. So, like, for instance, Breakthrough Listen is monitoring over 1 million nearby stars, along with the central regions of 100 nearby galaxies and several exotic star types as well. It is a massive project, but it still pales in comparison to the 100 to 400 billion stars in the Milky Way galaxy alone. And so I'm wondering, I mean, from your perspective, do the vast scales that are involved with this simply make it difficult for people to grasp the scope of work that's required in SETI?
Well, I don't know. That's hard to say, because when people don't grasp what we're trying to do, or what SETI is trying to do in general, very few of these people are asked, well, why is it that you don't grasp it? Is it because the galaxy is too big, or the number of stars is too large, that kind of thing? So we don't really know. But it is, as you say, Tim, it's an endeavor that involves big numbers. That's astronomy in general, right? Our neighborhood is the Milky Way galaxy, and the number of planets, forget stars, the number of planets in the Milky Way galaxy, we don't know, but on the basis of what we know about the frequency of planets, it's about 1 trillion planets you can expect are here in the Milky Way galaxy. And, most of those planets wouldn't be very interesting for life. But when you have 1 trillion of them, it's like buying 1 trillion lottery tickets. Most of them are losers. But if you have 1 trillion tickets, some of them are going to be winners.
Yeah, yeah. Well, could this massive search scope be narrowed a bit using the Kepler Orbital Telescope? I've heard that it's powerful enough that we may actually start detecting habitable worlds, maybe even biosignatures in atmospheres in the next decade. If this is the case, do you think that it might be able to help SETI pinpoint planets to focus attention on?
Well, it does that. I mean, when Kepler first went online and began finding planetary systems around other stars, people in the SETI community immediately put those star systems on their observing list. But, here was one, and here a couple more, and five over there. But these numbers are all very small. I think that the real impact of Kepler is not so much to say, well, this star has planets and that one doesn't. It's to say that, well, 80% of stars at least have planets. And once Kepler established that, which it has, then, what you do is you just look at as many star systems as you can, even though Kepler hasn't ever observed those systems. So you don't know if it has planets or not. But if planets are, commonplace to the extent that 80% of stars have planets, then it's all okay, because you just look at a large number of star systems and the majority of them will have planets. So that's been the impact of Kepler.
Ah, well, I also wanted to briefly ask about the next generation Very Large Array, which is an imagined concept, I guess. I believe it's in kind of the early planning stages, but I'd stumbled across this online when I was doing research. I just was like, this is so amazing. So it's a collection of 244 59-foot dishes spread over 5,000 miles. And again, I guess this is in kind of the planning stages. But the same way that Kepler takes optical astronomy to the next level from Hubble, this would take radio astronomy to a whole new level and give it completely new insights into solar system formation, black hole detection, even identifying clouds of complex organic precursor molecules in space, hopefully. So I'm wondering, if this is completed, is this something that SETI could use? Could you
Well,
guys get time?
yeah, Tim, I'm sure that SETI will figure a way to use it. SETI is a very sexy endeavor from the standpoint of the general public. And consequently, trying to do SETI on any telescope is usually regarded as something very favorable. But will it have a big impact on the search? Well, not so much, because, by extending the baselines, in other words, by building antennas, and these are fairly modest size antennas, I think you said 59 feet, so that's not a huge antenna, but building more of them or using more of them around the country or around the world has benefits for doing radio astronomy, because it allows you to see detail you otherwise might not see. So if you're studying, how black holes produce radio waves that get beamed out into space, which is one of the big topics of radio astronomy, having these big arrays really helps. But in terms of SETI, we're not trying to map their antenna farm. We're just trying to detect the signals. So from our point of view, the most important thing for any radio telescope is the collecting area. How big of a bucket is it for collecting radio waves? So this will help a little bit, but it's not like we're going to build 100 Arecibo antennas or something that had a really significantly larger collecting area.
Ah, okay. Well, that's good to know that. So I want to get into the Drake equation a little bit. This is an area that has been kind of a passion project for me over the last couple of months. Dr. Frank Drake created this in preparation for the first SETI conference. So this goes right back to SETI at the very beginning, which was held at the Green Bank Observatory in 1961, with a focus on radio search, not a search for primordial or primitive life forms. So that's a stated constraint that we're only estimating the number of advanced civilizations, but it also implies that we're only looking for civilizations that are openly communicating and doing so with radio waves, right?
Yeah, it has, as you just point out, it has some limitations. I mean, maybe the aliens are not broadcasting radio waves into space. Maybe they're just using, powerful lasers. And, that's something we haven't done very much of. But the import of the Drake equation, which was intended, as you say, just as an agenda for a meeting in Green Bank in 1961, but the import is that it sort of gives you a framework in which to discuss the likelihood that there's anything in this, that in fact, it pays to look for intelligent life elsewhere or intelligence of any sort elsewhere. Or is that just, a hopeless task, that kind of thing. So it's useful in that regard. It doesn't help you to decide where to aim your antennas, unfortunately.
Yeah. Well, for me, the Drake equation is compelling because it suggests that there could potentially be thousands, maybe millions of advanced civilizations out there just waiting to be found. But I wanted to ask what your guesstimates are on it. You have a much more educated opinion than I do. How many do you think are out there?
Yeah, it's like asking me to choose which lottery tickets you should buy. I don't have any, I don't have any edge there. But the point of the Drake equation was to estimate this quantity called n, and that's the number of societies out there in the Milky Way galaxy, right? That are, consist of intelligence of some sort, intelligent beings that are actually broadcasting now, so you have some chance of finding them. And nobody knows what that number n is because there are terms in the equation that we simply don't know. But if you ask Frank Drake, and I did ask him many times, well, Frank, what do you think n is? And he would say 10,000. That was his go-to answer, 10,000. In other words, in the Milky Way galaxy, there are 10,000 societies broadcasting signals we could pick up tonight, right, or tomorrow, or whenever. And but if you pressed Frank on that and say, well, where'd you get that number, 10,000, Frank? He would say, it just seemed like a reasonable number to him. Now, Frank was a very smart guy, and consequently, his guess would be better than certainly mine and many other people I know. But we don't really know the number of societies. The only point was, look, 10,000 is a big enough number that it pays to look for them. If the number had been 5 or 3 or something like that, and you're never going to find anything. And if the number's 1,000,000, you should be finding things all the time. So that's the value of the equation, but it doesn't give you the answer. There's no back of the book.
Yeah, yeah. Well, Robert Zubrin actually wrote a paper called Mistakes in the Drake Equation. And I did an interview recently with him on this. And he suggested that interstellar colonization and planets hosting multiple civilizations across their lifespan increase the probable number of advanced intelligent civilizations. So really, these aren't mistakes. These are just things that weren't in the Drake equation because they probably didn't occur to Frank Drake or they were too hard to estimate, I guess. But that would seem like it would increase the number of advanced civilizations on habitable planets. And it also introduces the idea of finding outposts and systems without habitable worlds. Is that something that you guys have looked at all?
Well, it's hard to do much with that idea, but it is a good point that the original Drake equation just assumed that, okay, there's a civilization over there and there's a civilization over there, and that was it. But in reality, if a society is advanced enough to broadcast strong signals into space, well, it might also be advanced enough to send rockets to other worlds and colonize them, right? so that in fact, if they were really aggressive about it, the amount of time it takes to colonize every habitable planet in the galaxy is on the order of, tens of millions of years. Now, that's a long time if you're waiting for a bus, but tens of millions of years is actually not that long compared to the lifetimes of stars or galaxies or anything like that. So the point is, if any society in the history of the universe, which is a 13 billion year history now, if any such society found it interesting to colonize other worlds, then they could have done it by now. Well, the bottom line of all this is that maybe there's just a lot of intelligence out there, but maybe it just traces its history back to one society, right? It's like Europe in 2,000 years ago. They were essentially all Rome, right? They're colonies of Rome. Maybe that's the situation in the galaxy, but we don't know. And in a sense, it doesn't change too much because it just means, well, the chances that you'll hear one of these outposts of empire might be higher than if they didn't colonize.
That's true. But the thing that inspires me about it is really the Drake equation implies that for each advanced civilization, there should be many more planets full of primitive life. And since each civilization has a lifespan, it's also likely that we'll find many more planets with ruins as well. And so I was trying to visualize the galaxy that way. Lots of life, lots of artifacts, and then a fewer number of active civilizations that would really seem to make civilizations like us stand out like this rare gem, I guess, in a garden, if that's a way to visualize it.
Yeah, that could be. I mean, it's sort of like, here's the galaxy and a society that gets to the point where its technology allows it to go on the air, right? That's like a flash bulb going off. But the flash bulb doesn't stay on for very long. It goes on and then, that society self-destructs or something else happens and they go off the air. Now, if that's the case, then you can imagine the galaxy is this big thing with a lot of flash bulbs going on and off all the time. And the question is, are you going to catch one of those with your receiving equipment before it goes off? That could be. But on the other hand, that's very speculative because we don't know if that's the case, if it's the case that the fate of all societies, once they become technically adept, is to disappear for whatever reason. Maybe they just unleash all their nuclear weapons or who knows. But that's alien sociology, and we really don't have any data there. So it's possible that that's the way things work. Societies arise and then they decline, and you don't hear from them anymore. Or it could be that a society gets to the point where it can make its presence known and has technology at a level that allows it to survive indefinitely, that it never goes away. Right. So, it can dominate the galaxy simply because it was the first that was able to do that. But we don't know. We haven't found any of these guys. There are a lot of possible models, but we don't know if any of them is correct.
Well, in terms of artifacts, there was speculation a few years ago about an alien megastructure around Tabby Star. And I believe that was just found to be a natural occurrence. It was an occlusion of the star's output, if I remember right, from something else. But science fiction authors have been writing about direct fusion drive torch ships and ring worlds and things like that for decades. And so one of the things that I'm wondering about is, do you think that SETI or perhaps even Kepler might be able to see some of these things, as our visibility into the galaxy increases, I guess, as our resolution increases? Do you think that we might be able to pick up artifacts as well as potentially traditional broadcasts?
Yeah, I think that would be a very interesting approach to SETI, to look for the artifacts instead of waiting for signals, right? Maybe they don't broadcast strong signals into space very, very much, but they might build big things, as you suggest. It's like trying to find the pharaohs of Egypt, right? You can find them from a satellite because they built big things, and you can see the pyramids from a satellite quite easily. So it could be that some aliens have done this, built something, they've altered their local universe. Maybe they've rearranged some stars or, built giant space colonies that are large enough to actually be detected, that sort of thing. I think that's a promising approach because it doesn't rely on the aliens, serendipitously transmitting signals just at the right time so that you can pick them up. It's just, the pyramids are always on, if you will, even though the guys who built them are long gone. It's a indication of sophisticated technology, if you will, that you can find at any point. So yeah, I think looking for artifacts is great, but nobody knows how to do it, right? Because we don't know what we're looking for.
Yeah.
And
Yeah.
so the only real point is, all right, if you're surveying the galaxy or the universe for that matter, just keep this idea in your mind that if you find something that doesn't look natural, to look carefully.
Yeah, well, and actually, that was why the torch ships came to mind, because if I remember correctly, I think Jerry Purnell had written about these a lot. He'd said that they would leave a flare that could be thousands, potentially tens of thousands of miles long, if I remember right. And I thought, that could be something, probably in the case of Kepler, where that would stand out, right? And much like the megastructures. But
Yeah, well, Kepler is one way to find them, but even just direct observation. But people figure, okay, there are a lot of telescopes in the world, and they're undoubtedly surveying all the nearby universe all the time. Unfortunately, that's not the case. The telescopes we build tend to have very narrow fields of view. In other words, it's like looking at the sky through a soda straw, and that means lots could be going on that you're totally unaware of.
Well, yeah, and that was one of the things I'm so happy that you put it that way, because that's one of the things that I think it's really important for people to understand is that, SETI is working very hard. It's just a massive galaxy. There is a lot to search through, right? So,
Yeah, yeah. Well, that's right. I mean, when people ask me, if they find out what I do for a living and I'm in a bar somewhere, not often in a bar somewhere, but, and they say, so, how are you looking for ET? And you describe it. And then they say, well, why haven't you found them if you think they're out there? And that's the answer. You can point the soda straw in a lot of different directions in the sky, but it takes a very, very long time before you've covered very much of the sky that way.
well, another type of artifact that, again, I'm personally very excited about this. I've been on a kick for quite a while about this, are von Neumann probes. And I know this is a little bit off the kind of the SETI path, but the thing that excites me about von Neumann probes is their efficiency for large-scale galactic exploration. There are absolutely no guarantees that these are feasible, but they model exponential growth patterns that occur naturally in cell mitosis. And it only takes one civilization building them to gradually fill the galaxy over time. Do you think that these may be out there? And if so, do you think that there might be a way to detect them?
Yeah. I don't find it unreasonable to think that some very advanced society has, in fact, peppered the galaxy with probes. Keep in mind, the galaxy is 3 times older than the Earth, for example. So there's been plenty of time for the inhabitants of some other world to advance to the point where they, sort of fill the galaxy with the remote sensing devices and, kind of keep a tabs on everything in the galaxy. That could be. I think it's very hard to do more than say it could be, because it would be very hard to find these probes, right? They could be the size of a bus or a truck or whatever, and still do a lot of observing. And to find a truck in space, unless it's got bright flashing lights on it for some reason, to find it in space at the distance of even a couple of light years, which is right next door, that's very difficult. That's difficult to the point that you don't expect that you're going to find anything.
Yeah. Yeah. Well, I also wanted to ask what your thoughts are on panspermia. Instead of robotic probes, there has been speculation that life is seeded either intentionally or accidentally through processes like what they call comet swapping. I don't think that this is something that SETI can detect today, but one thing that had occurred to me was if the next generation very large array can detect clouds of organic molecules, do you think that in the future there might be a possibility to actually detect life in between the stars?
Well, of course, you're going to look for that sort of thing, but it has to be an awful lot of it for it to produce a signal that could be detected. The idea of panspermia, which is to say that life can migrate from one star system to another, I think for me the appealing or interesting, in any case, aspect of that is that it sort of relieves a problem here when you hypothesize aliens, that life gets started on a lot of worlds, because you might think, okay, I'll just look at how many planets are like the Earth. I mean, there are a lot of planets that are sort of like the Earth, right? Presumably. And okay, well, if 1 in 100 or 1 in 1,000,000 of those planets eventually produces life, then you have some idea of whether you should even expect to find company in the galaxy. But panspermia changes that, just as you said, it isn't in the Drake equation, changes that by allowing life to spread. So it could be that, every other star system in the galaxy is populated by intelligent beings. I mean, that could be, right? And that may not be so improbable if they're all related to one another, that their history all goes back to one world that developed intelligence and then spread around. But,
Yeah.
We don't know.
Well, the improbable does happen. I mean, there are Mars asteroids, right? From impacts, if I understand this correctly, meteorite impacts on Mars kick up rocks that have actually landed on Earth. And so potentially, if one of those had life on it, that could be one vector for panspermia. Another is, as I mentioned earlier, comets, right? If microbes started in a comet over time, they could potentially just basically evaporate out of the tail and land in the atmosphere of various planets. So it's intriguing, very speculative, but intriguing.
Yeah. Yeah. Life can spread out. That's right.
Yeah.
Even microbial life. In fact, microbial life probably can spread out a lot better than any other kind of life. But again, we don't know. The problem with finding biologically important molecules in the remains of a comet, for example, is that normally you pick up something that fell to Earth, right? And when it falls to Earth, it's immediately contaminated. So it's a tough problem.
Absolutely. Seth, let me thank you so much for your time. Again, it's true pleasure and also definitely an honor to have you with me, and for the remarkable work that yourself and SETI are doing for humanity. I mean, all of this is just absolutely amazing. I'd like to close by asking, what is coming up in the near future for yourself and for SETI? Where will we be seeing you guys in future headlines? And, where should we be looking, I guess, in the next few months?
Yeah, in the next few months, it's hard to say, but I think that experiments like Project Cosmic, right? That's to siphon off some data from the very large array, a big array of antennas here, and use that for SETI. That's very interesting because it will collect more data than all SETI experiments since Frank Drake's Project Alasma back in 1961 or whatever it was. It was 1960, but whatever. That's interesting. But the other thing is the development of technology that can look for flashing laser lights and so forth, to look for a different kind of signal. Those are, things that are coming online, if you will, in the next couple of years. But the other thing that I find appealing is what we just discussed, and that is looking for artifacts, something that, very advanced societies have, if you will, built, right? We're going to Egypt to look for the pharaohs, and we find the pyramids, and that tells us the pharaohs were there. So that kind of thing. And that's hard to do because it's unclear what you have to do to find any artifact, because you don't know what the artifact might be. But on the other hand, it's just a big slab that enchants monkeys. I mean, we don't know. But in any case, all that requires is that you basically just do not radio. You just do astronomy in general, and maybe you'll trip across something.
Wonderful. Thank you again so much for your time today, sir.
Thank you, Tim. It's been a pleasure.